Hi guys, this is Miss Raina in C347 here at MacArthur High School, coming to you to talk to you about free fall today. Everybody should be following along in your guided notes page. And so we're going to start at Roman numeral 1, letter A. If we ignore air resistance, all the objects are going to fall downward. They're going to accelerate downward toward the Earth at 9.8 meters per second in the down direction. It means for every second that an object is falling, it's getting 9.8 meters per second faster. There's our acceleration due to gravity, and you have to either say that it's going in the down direction, or you can put a little negative sign in there to denote direction. So what's terminal velocity then? Because clearly not accelerating indefinitely, right? And it's all because of air resistance. There's a maximum speed that any falling object can achieve while it's falling toward the Earth. So have a look at this picture so you can kind of understand what's going on here. The longer you're falling, the faster you're going, right? The more speed you have. Well, the faster you're going, the more quote-unquote wind you feel moving against your direction of travel. The force of that air resistance at some point when you're going fast enough is going to balance out the force of your weight and gravity pulling on your mass. Once those balance out, then it doesn't mean you stop moving. You definitely stop accelerating. And so what happens next is you continue to fall, but you're going to fall toward the Earth without getting any faster anymore. You're going to be at a constant velocity. That speed for a person skydiving is usually between 93 and 125 miles per hour. It depends entirely on your weight and your shape as you travel through the air. Okay, so let's go ahead and write down some equations. This is the same one we talked about in class. So remember, final velocity is v sub f. V sub I is initial velocity. Usually this is the term that goes to 0. Because in this unit we're just going to be dropping objects, not throwing them down or up. What about this term here? Sometimes that's going to look like a g, like this. All that means is acceleration is due to gravity, so you can treat them exactly the same way. If we want to know how far an object has fallen, we can use the same old equation from the last unit. So again, keep in mind this might look like a g there, or we might just say acceleration due to gravity and call that negative 9.8 meters per second squared. Have a look at this term here. What happens to that initial velocity if we don't throw an object down or throw the object up? Initial velocity is going to be 0. 0 times anything is 0, so that whole term is going to go away. Lucky for us. Again, it's just another reminder. Sometimes you're going to see a G in here instead of an A. You can treat it exactly the same way. Write this in the bottom margin. If we want to know how long something has been falling, if I've given you distance, you can use this alternative. If all I've told you is the final velocity, you're going to have to use this equation instead. So it's all about picking the right equation based on what you know and what you need. Again, you're going to be able to do without that part because your initial velocity is, guess what? 0. What if I ask you how fast something is going when it lands, but I don't tell you how long it's been falling? In that case, you're going to need to know the distance. Since in this unit we'll be dropping objects and not throwing them up or down, this term will go to 0. Then all we have to do is take the square root of both sides, and we end up with a final velocity is the square root of 2gd. We're going to be able to report that in meters per second as long as we've used standard units. So take your first example. Go ahead and turn your paper over. Write this crisscross down on the other side of your actual notebook page. So since we know that the object takes 5 seconds to fall, we also know acceleration due to gravity is negative 9.8 meters per second squared. And we know that initial velocity is 0 meters per second. We're trying to figure out how far did it fall, so that means we want distance. We need to pick an equation that's got distance, time, acceleration due to gravity and initial velocity, or we can just say that's equal to 0. We'll end up choosing this one right here, and I'm going to write it this way. Distance is, I'm just going to put in 1/2 gt squared, because I know that that initial velocity is 0. Now all I've got to do is substitute. There's my distance, and it's going to be 1/2 of g multiply that by my time squared. Well, what's my time? It's 5 seconds. This is going to be about 25, or it's going to be 25 seconds. Geez. Here we go, 25 seconds. This is going to be about 5 meters per second squared. Sorry, that should be seconds squared. 25 times 5. I should end up with about 125 meters. These seconds squared, in case you missed it, canceled out with these seconds squared. So just an estimation. You guys can punch it into your calculator and see what happens when you punch in the actual 9.8. All right, next example. I'm going to let you guys do the next example. It says practice 2 on your own. I'm just going to tell you right now you're going to use the same equations. So let's try example, and it says Roman numeral 6. It says practice 3. Okay, so let's pretend there's an elevator. It started out on the 3rd floor, 120 meters high. What speed does the elevator travel once it's hitting the ground at the bottom? We used to have cats in all our problems. Other students kind of like got offended at that, so we started taking them out of the problems. In this case, for all my old students, you're going to be very happy to know there are no kittens in this elevator in this problem, but our job is to figure out with what speed does the elevator strike the ground and how long did it fall. Okay, so we know that it traveled a distance of 120 meters. We also know that the initial velocity is 0. Finally, we know that acceleration due to gravity is 9.8 meters per second squared in the down direction. Our job is to figure out with what speed does the elevator strike the ground, so we want to know final velocity. And we also want to know how long did it fall, so we got to solve for the time. That's supposed to be a t. Alright, so I know my distance is 120 meters. I know my initial velocity is 0 meters per second. I know acceleration due to gravity is negative 9.8 meters per second squared. I'm supposed to figure out, hope I have enough room here, what is the final velocity as it hits the ground. And I'm also supposed to figure out how long did it take to hit the ground. Alright. This looks to me like I need to pick an equation that has distance, initial velocity, gravity, and final velocity. So I'm going to go ahead and pick that final velocity squared is initial velocity squared plus 2gd. In this case, I know my initial velocity is 0, so in order to get my final velocity, I'll just take the square root. Sorry, that's messy. It'll look better in class. In short, all I got to do is take the square root of 2 times gravity times the distance that it fell. You might say, hey, that gravity is supposed to have a negative sign. Well, technically, so is that displacement because it fell down. So we won't have a negative inside of a square root. I'll let you guys punch that into the calculator and tell me what it is in class. Finally, I need to know, well, how long did it take to fall? I have a choice. I can use the final velocity or I can use the time equation. So I can say distance is 1/2 gt squared. Okay, well then time must be 2d over g square rooted. Plugging that in, I can take the square root of 2 times my distance, divide that by gravity, and punch that into the calculator and you have your answer. Thank you very much for watching this longer video, but I wanted to be able to give you some examples of some practice problems. So you guys can pause, rewind, fast forward, however you like. Make sure you write down any questions, bring into class tomorrow. We're going to be doing some of these practice problems in class together and as individuals. So thanks again for watching the longer video.